Hi, so in this video, I'm going to show you how to differentiate with inverse trigonometric functions. So these three standard derivatives are provided in the Edexcel formula booklet, but I'm going to show you how to find the derivative of arc sin x and arc tan x. Okay, so we're going to find the derivative of arc sin x. So the first thing that we need to say is we're going to let y equal arc sin x. And now we're going to take the sine of both sides. So the arc sine and the sine will cancel. So we're left with the sine of y is equal to x. And now we're going to differentiate both sides. So we'll have implicit differentiation on the left side. So this becomes cos y dy by dx is equal to 1. We can rearrange this now to make dy by dx the subject. So dy by dx is 1 over cos y. But now we can use the trigonometric identity to take this further. We know sine squared y plus cos squared y is equal to 1. So cos squared y will be 1 minus sine squared y. And then we can take the square root of both sides. So cos y will equal 1 minus sine squared y, square rooted. But we said here that sine y is equal to x. So this term becomes x squared. So cos y is equal to the square root of 1 minus x squared. Now I can substitute this expression for cos y into our derivative. So this becomes dy by dx is equal to 1 over cos y, the square root of 1 minus x squared. Okay? So let's try example B. So for example B, we're going to say let y this time equal arctan of x. And like we did a minute ago, we'll take the tan of both sides, and this will cancel out the arctan. So tan of y will leave us with x. And we'll differentiate both sides with respect to x. So the left side will be implicit. We'll get sec squared y dy by dx is equal to 1. So dy by dx will be equal to 1 over sec squared y. But we know that sec squared is 1 over cos squared. So this can be written as cos squared y. But the problem now is we don't know what cos is. But we have the information that we can use from this. We know that tan y is equal to x, but it's also equal to x over 1. So now we have our triangle. We have our angle y. The opposite side will be the x, and the adjacent side will be the 1. So the hypotenuse will be the square of the two shorter sides, square rooted. So x squared plus 1 squared, or x squared plus 1. So now from this triangle, we can work out cos y. This will be the adjacent 1 over the hypotenuse, the square root of x squared plus 1. So now we can substitute this value of cos y back into our derivative, and we get 1 over the square root of x squared plus 1 all squared. Well, when we square our numerator, we get 1. And when we square the denominator, the square and the square root will cancel, so we're left with x squared plus 1. And this is the standard derivative for the arctan of x. Okay, so in example 2 and 3, I'm going to show you how we can use these derivatives to solve more complicated problems. Okay? Okay, so in example 2, we've been asked to differentiate the arc sine of 2x with respect to x, but we can use this derivative here. And we also need to remember the chain rule. So if we say that x maps onto 2x, all we need to do is substitute this 2x into here. So this will be d by dx will give us 1 over the square root of 1 minus 2x squared. But then we need to multiply this by the derivative of this in a function, which is 2. So we'll multiply this by 2. So the derivative will be 2 over the square root of 1 minus 2 squared is 4. So 4x squared. Okay? Let's try one more question. Okay, so finally, in example 3, we're going to use the product rule to differentiate 1 minus x squared multiplied by the arc sine of x. So the first thing we'll do is we'll say let u equal 1 minus x squared. So then du by dx will be minus 2x. We'll let v equal the arc sine of x. So dv by dx will then be 1 over the square root of 1 minus x squared. So now we'll substitute these into a product rule. D by dx will be u 1 minus x squared dv. So multiply by 1 over the square root of 1 minus x squared plus v, the arc sine of x, du, so times negative 2x. We can write this as a fraction, so 1 minus x squared over the square root of 1 minus x squared. I'll move this negative to the front, so minus 2 arc sine of x multiplied by x. And for this expression, where we can simplify this, if we have this raised to a power of 1 divided by the same raised to a power of a half, well, this becomes 1 minus x squared to the power of a half, which is the square root, minus 2x arc sine of x. So this will be the derivative for this function. Okay? Well, thank you very much for watching. I hope you found that useful. You can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again, and take care.